a diagram by which we can see the photophysical process. The content of my topic is Jablonski diagram, its definition, different energy states, whether it is singlet or triplet, different transitions which are spin allowed or spin forbidden transitions. Spin allowed transitions are tunnel conversion and spin forbidden transitions are inter-system crossing. The next part of the content is fluorescence and phosphorescence. In this Jablonski diagram, we can see, or the Jablonski diagram illustrate the different photophysical process. The Jablonski diagram related with the photochemistry, and the photochemistry deals with the study of radiation in between 200 nanometer to 800 nanometer. The Jablonski diagram proposed by Alexander Jablonski in 1933, which explains the different photophysical process. These photophysical processes are, or we can say the Jablonski diagram includes different electronic, whether it is vibrational levels, electronic levels, different transitions, radiative and non-radiative transitions, multiplicity, singlet and triplet, internal conversion, intersystem crossing, fluorescence, spin allowed transitions, phosphorescence which is spin forbidden transition. All these things are explained by the Jablonski diagram, or we can say it is picturized in the Jablonski diagram. First of all, we understand what is the multiplicity. Multiplicity are two types. One is singlet and another is triplet. The formula for multiplicity is 2s plus 1. S is the spin state. We know that in a orbital there are two electrons which are anti-parallel in their spin. Then the value of S becomes 0 due to cancellation of spins by the each other. There are two type possibilities for the singlet. S becomes 0 because the electrons are anti-parallel. When electrons are anti-parallel, then they cancel the spin states by each other. Then S is equals to 0, then we put the value of S is equals to 0 in the formula, or in the formula of multiplicity 2s plus 1, then we got the result 1. 1 is a single number, then it is known as singlet. For the triplet state, the electrons becomes parallel, then the value of S becomes 1 because plus half and plus half becomes 1, then multiplicity becomes 2 into 1 plus 1 equals to 3. Then this state is known as triplet state. By the multiplicity there are two steps. One is singlet and another is triplet. Here we can see the Jablonski diagram which shows the energy states, absorption, non-radiative transitions and fluorescence. In this diagram we can see a thick line which is electronic state, this and this is electronic state. In this diagram, in the ground state there are so many vibrational states. These are in the ground state, so these are known as singlet ground state. But upper side we can see the singlet excited state. The singlet states are two types, becomes two types: singlet ground state, lower energy levels, and singlet excited state, higher energy level. In these states, when a molecule absorbs the radiation in the range of 200 nanometer to 800 nanometer, then it absorbs the radiation and become excited. It moves from ground state to higher energy state. When it moves from ground state to higher energy states, it absorbs the radiation. But from the higher energy excited states, it's release the energy in the form of radiation or non-radiation. When it moves from higher energy excited states to lower energy excited state, then it release the energy in non-radiative form, which is in the form of heat. But when it move from excited singlet state to excited ground state, then it release the radiation in the form of fluorescence. So this process is known as fluorescence. Fluorescence have many characteristics. It observes in solid, liquid and gas. It is a radiative process. Multiplicity remain the same. Absorption of light takes place in UV or visible region. It occurs when transition takes place from singlet excited state to singlet ground state. Emission of radiation in form of light. Lifespan is 10 to power minus 6 to 10 to power minus 4 second. It means it is a very low time. It is spontaneous process. It is stopped as the source of light remove immediately. Transitions are two types: spin allowed transitions, internal conversion, and spin forbidden transition is intersystem crossing. We can see the differences in between spin allowed transition, internal conversion, and spin forbidden transition, intersystem crossing. First of all, spin allowed internal conversion. It is non-radiative process, no emission of radiation. It occurs when the electrons move from higher excited state to lower energy state. Energy released in form of heat, spin of electrons remain the same. But in spin forbidden, or we can say intersystem crossing, it is a non-radiative process also, no emission of radiation, but it occurs when electron move from higher excited state to lower excited state, S1 to T1 or T1 to S0. Energy released in the form of heat, spin multiplicity of the electrons change. Intersystem crossing have more time to complete than internal conversion. When the spin multiplicity of the electron change, then it takes some time to convert it. In this Jablonski diagram, we can see the two process, fluorescence and phosphorescence. In the previous picture, we have seen the fluorescence. It occurs when the electrons move from lower energy state to higher energy state, and when it comes from higher energy state to lower energy state, it release the radiation in the form of fluorescence. At this excited state, the electron move from higher excited state to, or we can say singlet excited state to triplet excited state. In this process, the heat in the form of intersystem crossing. But when it move from excited triplet state to ground state, it emit the radiation in the form of fluorescence. So this process is known as fluorescence, or we can say that when electron move from excited triplet state to ground state, it emit the radiation. This process is known as phosphorescence. Phosphorescence also have many characteristics. It is a forbidden transition. It observed in solid only. Radiative process. Multiplicity change on emission, triplet to singlet. Absorption of light takes place in UV or violet light region. It occurs when transition takes place from triplet state to singlet ground state. Emission of radiation in form of light. Lifespan is 10 to power minus 4 to 20 seconds due to spin conversion. It can be seen after the removal of source of light. This is all about the Jablonski diagram. Thanks.